There are several types of relationships that we look at when we're looking at graphs, and it all comes down to positive and negative and what we call curved relationships is what we're looking at here. When you think about a graph, you've got your x-axis, you've got your y-axis, and in our case we normally plot our dependent variable on the y and our independent variable on the x. And when you think about it, we have 4 quadrants in this graph. If it goes up this direction, it's a positive. If it goes this direction, it's a positive. If it goes this direction, it's a negative. And this direction is a negative. So if we have a line that's going like this, that means as one variable increases, the other variable increases as well. We call that a positive correlation, just like this. Now, if you tend to have a lot of error in your data, you'll have what we call a moderate positive correlation because your data is actually spread out away from your average line because of error usually, or other variables affecting the relationship. If you have one variable increasing but the other decreasing, you end up getting a graph line that looks like this. And we call that a negative relationship or a negative correlation because as our independent variable is increasing, our dependent variable is actually getting smaller or going down. The last relationship we're going to look at is this one, which is a curved relationship. Now, a curved relationship means that you cannot plot a straight line there accurately at all. And we actually have to look at other mathematical equations to express this relationship. The linear one is actually covered by the y equals mx plus c equation, but we'll go into that another time. The curve relationship is where we start to get squares and powers in there. Now, curve relationships are seen an awful lot in nature. We don't often see perfectly linear relationships, and I'm going to show you some curved relationships from nature now. The two ones that you'll see an awful lot are what we call a J-curve and an S-curve. J-curves are also known as exponential graphs because the y value actually increases what we call exponentially. Now, we call this a J-curve because, as you can see, there's an obvious J shape here. Now, an example of this is the human population up until now. We've actually increased in such a high rate that it forms a J-curve on a graph. Now, that you see this when essentially you don't have factors limiting growth. And in the case of human population, especially because of the amount of food that's available and the medical treatment and that we have, we're actually seeing an exponential rate of growth. But eventually that's going to stop because food is starting to shorten out. Now, in nature, we don't see exponential growths like this unless you find, say, an invasive species coming in. In nature, we see this S-curve here. And as you can see here, the S seems to be apparent on this graph. Sort of, like if you look at that, that's like an S. Okay, you just got to use your imagination a little bit. Now, in real life, we see this often, especially when population limits reach factors that are affecting their limits. So you get to a food source is going to limit a population's growth, or if there's too many people in a city, eventually you're going to have disease spreading quite quickly because people are packed in so tightly. So limiting factors like food and disease and water will actually stop an exponential graph and turn it into an S-curve quite quickly in nature. So there are two different types of graphs that you'll be looking at and analysing in different biological investigations we go into.